Hello, my name is Christian Drews, and this is a review of the paper titled A Review of Image Steg Analysis Techniques for Digital Forensics. So here is just a brief citation of the authors and the paper. Um, was found with Google Scholar, and it is part of a journal of information security and applications. So let's just do a quick overview of the topics discussed in this paper. One is steganography in cybercrime, steg analysis and tools used against steganography, techniques and attacks, and types of image steg analysis. So what is steganography? So steganography is the art of hiding messages, and this was used in ancient times, back in earliest recorded times of being the 400s BC. So what would happen would be the Greeks would write hidden messages into the scalps of their messengers and wait for the hair to grow and then send them off to whoever they were trying to communicate with. Um, this was this is kind of the basic idea of steganography as a hidden message out of plain sight is used and could hide various different things. Um, the word steganography actually comes from a Greek word of steganos, which is to cover, and grapho, which is to write. So, what is steganography in modern times? So this could be used with digital images, videos, many different types of files. Um, in some cases, a not only a message could be hidden in the file, but also an image. As you can see, this example here, we have this tree, which is considered the cover photo, and then we have our hidden message here, and this is embedded inside this message here. As you can tell, there's no way of really knowing that with the naked eye. So another confusion between stenography um, is often with cryptography, which cryptography is more so scrambling a message, and the only way to unscramble it or to decipher it is with a proper key. And one interesting thing to note about cryptography is that it is actually forbidden in a lot of countries, and so this kind of actually drives up the rate of stenography that is used to hide cryptographic information, since cryptographic information is usually easily detectable. So another topic is steg analysis. So what is steg analysis? So steg analysis is the opposite procedure of steganography. It can be used to detect the presence of steganography, and there really are two main categories of steg analysis, which is passive, essentially is finding a file that has got a steganography algorithm that has been used to embed information in it, and then active, which would be more so to extract that information from the file. So here's a few different techniques used in digital forensics um, and steganography. We have the stego only attack, which is whenever the stego object is available for analysis. A known cover attack, which is the cover and the stego object are both available for analysis. A known message attack, which the message is known and can be compared with the stego object. A chosen stego attack, which is stego object, and the stego tool or algorithm are available for analysis. A chosen message attack, where the steg analysis generates stego media for some stenography tool or algorithm from a known message. The goal in this attack is to determine corresponding patterns in the stego media that may point to the use of specific stenography tools or algorithms. And then we have the known stego attack, in which both the algorithm, the original, and the stego object are available. So usually in these different methods, it is a lot easier to find a file in which a hidden message is embedded inside, but it's much harder to actually extract it. Um, and what's really worth noting here too is that as we see digital media increase over the years, um, digital forensics examiners need to be able to keep up on these different types of uh, stenography and stegananalysis techniques and tools. So there is a few examples. There's many different examples of tools online. Just searching steg tools or stenography tools, I mean, you come up with a giant list of them. Here's just a few sample ones that I found interesting. VSL Virtual Stenography Laboratory here. It's open source software to detect um, stenography being used on an image. Same for this here, Steg Detect. Pretty much the same thing. I don't think it's open source though. And then Steg Alzer, which is more general, and it's actually used to scan entire devices, looking for any indication of hidden messages in any media. So what are some techniques used in image steg analysis? So there are two major approaches that digital forensics use on image steg analysis. Usually to extract features from a target and from a clean image or untampered image. We can compare these statistical features and determine if a target is subject to stenography. More so, a newer technique, something that is um, starting to become more commonplace, is the use with machine learning. Uh, it uses the similar features, extracts features from these images with machine learning models. We can train these models up on various different stenography techniques, and we can train those to discover and distinguish differences, and these usually are much more accurate and much faster. Further research has been done to analyze the results of this model and the features, and when comparing many different formatted images. So let's look at spread spectrum steg analysis. Spread spectrum image stenography was first described by Marvel and and other researchers, and embeds the hidden information within noise, which is then added to the digital image. This noise is kept at low levels and is not distinguishable to the human eye. Harmson and other researchers presented a spread spectrum steg analysis method for color images using histogram characteristic function, which is the Fourier transform of an image of histogram, and exploiting the properties of center of mass of HCF, where center of mass is the first order moment, Two different experiments were conducted. The first detected images when the embedding method was known, and the detection rate was about 94%. And the second one detected images when the embedded method was unknown. The detection rate in this case was about almost 96%. In both cases, the embedding rate was of 1 BPP. Universal steganalysis tries to detect the embedded messages regardless of the steganographic technique applied to cover image. The main difficulty is to find relevant features which are characteristics for stego images. Afterwards, machine learning techniques are used to build a detection model from the experimental data. When the method identifies stego images regardless the steganographic method, the hidden message was embedded in cover medium. We can call it the universal or blind method, while when the method attacks specific steganographic algorithms, we may call it a semi-blind one. Well, visual steganalysis. The visual attack is the examination of the suspicious image with the naked eye to identify any noticeable discrepancies. This turns to be very difficult since the alterations made to an image when a message is embedded do not result in quality degradation. Most stenographic algorithms create a stego objects that are similar to the cover medium. However, when unaltered parts of the stego image are removed, it is possible to observe signs of manipulation. Hence, if a steganalist can identify those features of the image that characterize it as a stego, a visual attack may reveal the existence of a hidden message. The most common form of a visual attack concerns least significant bit, or LSB, steganography. The image is converted to its binary form, and the bits in the LSB plane are retrieved. So here is an example. Here you can we can see that there's two different images. However, one of them is a clean image and one is a stego image. Can you determine which is different? And it's not actually possible to determine with the naked eye, but this is why we have different tools and techniques here. So using the LSB techniques, uh, we can pull up these two different images, and using either a feature-based or a machine learning-based model, we can actually look at these. It will look at these and determine which is which. So here we had on the left was the clean image, and then on the right is the stereo image, and which determined the right to be the embedded image. So let's look at signatures steganalysis technique. In some software for stenography, certain words or certain headers, various things could be left behind when embedding a message or a photo. In this case, this tool picked up the string CDN, in which a common stenography tool had left behind, so it's easy to detect that there is something hidden in this image. So LSB replacement. In LSB replacement, the cover image bytes have their least significant bits replaced by secret data. There are two different embedding schemes in least significant bit substitution algorithms: sequential and randomized. So sequential embedding denotes that the algorithm starts with the first pixel of a cover image and embeds the bits of the message data in order until whole message is embedded. With randomized embedding, it disperses the positions of the values that will be modified to contain the bits of the embedded data. Various techniques are actually used in this LSB replacement as well. Westfeld and Fitzman proposed that the first statistical steg technique. The technique identifies the pair of values exchanged during message embedding. The pair of values, or POVs, can be pixel values, quantized DCT coefficients, or palette indices that differ in LSB. Westfeld and Fitzman claimed that the frequencies of each of these two pixel values in the POV tend to lie far from the mean of the POV. Frederick and other researchers proposed that a method for detecting LSB embedding in 24 color images, the so-called raw quick pair, or RQP method. The RQP analyzes close pairs of colors created by LSB embedding. Close color pairs indicate the two colors differ only at LSB, and the process of embedding messages into images increases the number of close color pairs. Therefore, by counting the number of close color pairs, we can characterize an image as stego or not. And the authors showed that even for secret message capacities 0.1 to 0.3 bits per pixel, it is possible to achieve a high degree of detection reliability. More of these LSB replacements was activists and other researchers used image quality metrics selected based on an analysis of variances, or ANOVA. This is a technique as features sets to distinguish between cover images and stego images. The classifier between cover and stego images was built using multivariate regression on the selected quality metrics and was trained based on the estimate of the original image. The embedded message sizes were 1 in 10, 1 over 40, and 1 over 100 of the covered image size, depending on stenographic scheme used. The detection rate varied from 65% to about 80%. Liu and other researchers used high-order statistics to capture certain properties from natural images. These properties were used as features to train a SVM. Several experiments were conducted depending on the varied embedding rate in the stenographic algorithm, and the attained classification accuracy reached about a maximum of 94%. So there are many other different LSB replacement that is being used, but I would like to cover two on some LSB matching. An LSB replacement technique is actually proved to be really vulnerable. And in order to avoid certain statistical attacks, Sharp introduced LSB matching stenography technique. In LSB matching embedded algorithms, each secret data bit is compared with the least significant bit of the corresponding cover byte. If the two compared bits match, no change is made, while in the case of a mismatch, the cover byte is incremented or decremented at random. So, looking at the equation below, you can let C is the cover image and CI is the ith LSB bit. M is the hidden message, and MI is the ith bit of M. S is the resulted stego image, and SI is the ith LSB of this stego image. So let's look at the conclusion. Image steg analysis is rapidly evolving to keep up with the varying techniques in stenography. As mentioned, there are many different techniques to find these hidden messages, and as machine learning models and other tools become more advanced, so do the methods of finding these messages. It's important that the digital forensics examiners keep up with these methods of finding hidden information, and that they stay one step ahead of cyber criminals that are using these techniques with malicious intent.